In the power supply unit, mechanical energy is converted into hydraulic energy, and the hydraulic fluid is conditioned. The main components in this unit are the drive motor, the safety valve, the oil reservoir, and the pump. This is an external gear pump. It creates a continuous flow of fluid. And this is how that's done. The suction chamber is connected to the oil reservoir. When the two gear wheels turn, the volume of the chamber increases slightly whenever a tooth leaves a gap. This creates a partial vacuum in the suction chamber, which then causes the oil to be drawn out of the reservoir. Oil is transported between the gear teeth along the chamber walls to the pressure chamber. The intermeshing teeth prevent the oil in the middle from flowing back. The oil now flows from the pressure chamber into the line, where it is displaced by the oil being supplied continually from the gear wheels. Initially, the pump doesn't create pressure, but only a fluid flow. Not until the fluid meets with resistance, for example line resistance or a load, as in the case of our platform lift, does hydraulic pressure build up. When pressure is higher than the resistance of the workload, the piston begins to advance until it reaches its end position. If the pump continues to supply fluid and pressure continues to rise, something will eventually have to give. Either the line will burst or the pump or cylinder will be damaged. This is prevented by a pressure relief valve, which is set to the maximum pressure of the pump. It doesn't open until this pressure has been reached, at which time it channels the hydraulic oil back to the reservoir. It's usually combined with a pressure gauge to form a unit. This external gear pump generates a constant flow rate. So what we have here is a constant action pump system. The oil reservoir in a hydraulic system has several functions. First of all, it holds the oil supply for the system and takes up the unpressurized oil flowing back from the system, which it then cools. But also, suspended matter, water, and air must be removed from the oil. In order for the oil to remain in the reservoir long enough for this to be achieved, the reservoir must have a large enough capacity. Before the oil leaves the reservoir and returns into the system, it flows through a filter that traps any remaining impurities. About 70% of all malfunctions in hydraulic systems are due to impurities in the oil. This is why it's so important to service the filter unit regularly. Incidentally, there are filters in the suction line, or in pressure lines, or in the return line.